Ladies and gentlemen, what's up? Here we go, section 3 of chapter 2. And in this section, here's what we're going to talk about. How do you use slope-intercept form? Yes, that should ring a bell from Algebra 1. And this thing called x and y-intercepts to graph linear equations on these little coordinate planes. Now, what we're going to talk about in the first one is, if we have a point right here and we use a slope, we go up and we go over to the right. Rise over the run, we put another dot, boing, 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 and we graph that line right through there. We're going to learn how in this video to use slope-intercept form to graph a line like that using rise over the run and y-intercept. Okay? The other thing is we're going to talk about x and y-intercepts. So we're going to find the y-intercept where the actual graph crosses the y-axis and the x-intercept where the graph crosses the x-axis, wherever that happens to be, and then just simply draw a line right through those, bingo, and we'd be done. So that is the topic of this video. And let's do it! So here we go. On your graphic organizer, if you don't have it, just write this down. What we're going to do is I'm going to show you how to graph this equation, linear equation, 2x minus 3y equals negative 12. And yes, there actually are 3 methods. In this video, we're only going to talk about 2. But the other method would be this. You would say over here, okay, let's choose our x, and let's make a nice little table, and let's evaluate whatever y is, and make your x and y table, and say, great, let me choose some x's, let me choose, whatever, and then plug this in here and plot the numbers over there. So you could choose x to be 0, you could choose x to be negative 4, you could choose x to be 107, you could choose x to be 1/2. It's your choice. We talked about that a couple sections ago. That is an option. But these 2 options here might actually be the better 2. Yes, table is nice. But let's talk about using the slope-intercept method to graph this particular equation on the coordinate plane. First thing we'll talk about, which needs to go in your graphic organizer and or your notes, I'd highlight this. What is slope-intercept form? Well, most people, when I ask them, they remember from Algebra 1, it is this. Y equals mx plus b. And that's exactly what it is. Notice here is a very key thing. This is solved for y. So when you're putting something in slope-intercept form, write that down, highlight it. You need to solve the equation for y. The example that we have up here, it's not solved for y yet. We're going to need to do that. Sometimes it's already going to be given to you guys in slope-intercept form. This is an unbelievably awesome method to use then if it's already given to you in slope-intercept form. However, sometimes you need to do a little work to do that. And in this example, we'll do it. But that's the first thing I got to tell you. You've got to make sure that you, at least when you're using slope-intercept form, it's solved for y. This other thing, just to make sure we're clear, remember, that right there, the m stands for, of course, the slope. You can write this in your notes. And then, of course, this thing right here, the b stands for wherever the graph is crossing the y-axis. We call it the y-intercept. So it's where the actual line crosses the x-axis like this, or whatever. I said x-axis again, I mean y-axis, sorry. So that is the deal. Now, here are your steps. You can see in your graphic organizer there's actually 4 steps to your success to graphing these using the slope-intercept form. I'm going to pop them up here on the screen as we go. You can pause it and write them down. But here is step number 1 in graphing this using slope-intercept method. Number 1, you need to make sure, as I already said, you need to write the equation in slope-intercept form, aka you need to solve it for y. So we need to take this goofy thing right here and solve this guy for this y right there. So I'm making that y me. Remember, we want to get rid of the cat first and the dog second. So let me subtract 2x from both sides. And these are not like terms, so I'm going to come over here so you can see what happens. So that means I'll just be left with a negative 3y equals negative 2x minus 12. Why is that? Because again, negative 12 and negative 2x are not like terms. So I would just write it as negative 2x minus 12. Side note, you can write this down if you want. I'd always write the x first because look up here in the actual slope-intercept form, x is always written first up here. Just a little side note. Now, that's step number 1. Step number 2, you're going to, well, we're not even step number 2 yet. We still haven't solved it for y. Modder, don't get ahead of yourself. I still have to get me, the y, by itself by dividing by negative 3. And when I divide the left side, I divide everything on the right side by negative 3. So these guys cancel. Hello, hello, hello. I have y by itself. That is step number 1. This here, I'm going to put the negative 3 underneath the negative 2, but the negatives actually cancel out. So I'm left with 2 thirds, x, just like that. And then this here, I have a negative 12 over a negative 3. Don't forget that's there. Negative 12 over negative 3. Actually, it'd be better for me to write it like this. I would do negative x over negative 3, and then plus negative 12 over negative 3. I would take that negative 3 and put it underneath both of them. So that means these cancel, so I'm left with 2/3 x. And then this over here, actually these cancel too, so I'm left with just a positive 4. So there, beautiful, is step number 1. And everything, ladies and gentlemen, from here on out comes from what I just put in that box, because everything's right there in front of you to graph this linear equation using slope-intercept method successfully. So here's step number 2. Pops up on the screen. You're going to want to plot the y-intercept. And remember, the y-intercept is where this graph is going to cross the y-axis, which is represented by this thing right there. So at positive 4 on the y-axis, I'm going to put a dot. That right there is my y-intercept. Remember, the B is my y-intercept. That's step number 2. Step number 3, you're going to then start at the y-intercept. And you're going to rise, you're going to run, and then you're going to plot. That's right. Rise, run, plot. Rise, run, plot. Rise, run, plot. Rise, run, plot. Where's the rise and run coming from? The slope. And that happens to be, let me change colors, that happens to be right here. So I'm going to take this slope, which is 2 over 3. So my rise is always first. I go up to 1, 2 from my y-intercept. So I start at y, my y-intercept, up 2, and then I got to go over to the right 3 and I plot. Rise, run, plot. Rise, run, plot. Now I'm actually out of real estate up here in my graph, so what I'll do is I'll just go in reverse order. Instead of rising to the top and going to the right, I'll go down 2, back 3. Ew, looky there. So it looks like a nice straight line. I'll go down 2, back 3. Because what I'm doing is going down 2, back 3. It's the same thing as positive 2/3. Same thing. So that is step number 3. And you see it right there in front of you. Step number 4 is just simply draw the line, connect the dots. La, la, la. That is all you have to do. So I'll go from here, connect the dots, draw my line like that. Make sure it goes the whole way through my graph with a line on either side. And ladies and gentlemen, congratulations. You're done using slope-intercept method. Woohoo! Okay, over to the right side of your graphic organizer. Let's now use the different method to graph the same thing. So you know what it's going to look like. It's going to look like this. Whoa, that's not what it's going to look like at all. There. It's going to look like that line right there. That's the goal. We know that that's correct, so let's use a different method, using x and y intercepts. So what we're doing is we're going to find where the graph crosses the x-axis, and we're going to find where the graph crosses the y-axis. Now you already know from the last method that we did, it crosses the y-axis at positive 4. However, let's say that you're given this equation like this and it's not in slope-intercept form. That's okay. Technically what this thing is given to you is, and this is up at the top of your paper, standard form. When something is written in standard form, it looks like this, where you have some type of a number with x, and then some type of another number with y, and then on the right side, or the left side, or by itself, whatever, is another number. That is standard form, when you have ax plus by equals c. So technically, standard form is when you have the x and y's on the same side of the equal sign, with just a number on the other side, aka like it's written right there. So you don't do anything different with this one. You don't have to put it in slope-intercept form. If you're going to use the x and y-intercept method, which sometimes it's a beautiful, beautiful thing. Sometimes it's much quicker, honestly, and much more efficient and effective than using the slope-intercept form. But that's what we'll talk about more in class when we practice these, to see which one's better and which one's not. So here are your steps. Step number 1. If you're going to use this standard form x and y-intercept method, you need to step 1, make sure you write the equation in standard form. That's step 1. Now, again, sometimes it's already going to be given to you like that, like this one already is. So this step number 1 is already done. Here comes step number 2. You have to, step 2, find the y-intercept. How am I going to find the y-intercept? Well, if I want to find where it crosses the actual y-axis, that means my x-coordinate would be 0. What are you talking about? If I put a dot right there, what's the order pair? 0, 2. If I put a dot right there, what's the order pair? 0, 4. If I put a dot right here, what's the order pair? 0, negative 2. If I put a dot right there, what's the order pair? 0, negative 5. Look at all the x-coordinates. They're all 0. So if I want to find where the graph crosses the actual y-axis, like here, here, and here, I want to put 0 in for x and figure out whatever y is. That's the concept. So let me get rid of this. Bye, 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 bye. So let me put 0 in for x, and let's solve this thing for y. So I will do this. I'm actually doing this, and I'm looking for that right there. So let's put 0 in for x. I put 0 in for x right here. That gives me 2 times 0 minus 3 times y equals negative 12. So now I substituted 0 in for x. I'm just going to solve it for y. This gives me 0 minus 3y equals negative 12. So when 0 is gone. So divide by negative 3. That gives you y equals positive 4. So we already know this. The graph already crosses the y-axis at 0, 0, 4. It's beautiful. So that's step number 2. Step number 3 now is to actually go and solve for the x-intercept. And again, that would be where the graph crosses the actual x-axis, wherever that happens to be. But same argument. That means then 0 is going to be representing whatever y is. Because no matter where you put an ordered pair here on the x-axis, no matter where, the y-coordinate is always going to be 0. So let's do that. I'm going to find the x-intercept by seeing where the x is if y is 0. So let's put 0 up in here for y. Up in here, up in here. And I want to see what x equals. So let's do this. We'll start evaluating. We'll start calculating. This negative 3 times 0 is 0, so this is actually gone. So I'm left with 2x equals negative 12. So x is actually equal to negative 6. So this graph crosses the x-axis at, whoops, I don't know where this went, at 4 up here. And now the x-axis crosses at negative 6. Well, it's over here. Right there. So at negative 6, 0, and at 0, 4, those are my intercepts. Well, now look at that. I have 2 dots. That looks like my line is going to go right through, and it does. That's step 4. Connect the dots, la la la. So when I graph this bad boy, it'll go right through here like this, like that. So extend it the whole way, extend it the whole way like that, and draw your arrows. So there you go. Let's see if it looks like the same as the other one. Oh, it does. Oh, look at this. Weird. This one actually went through negative 6 right over here on the x-axis. So did this one. And that's what we did algebraically right there. So beautiful. There are your 2 methods. Slope-intercept method and x and y-intercept method. Now, since the video is about 12 minutes, I'm going to stop it right now. Don't worry about the CPQ question. Go back and review these notes. You got everything that you need to on your graphic organizer. Please make sure you got detailed notes because we're going to refer to these a lot in class. You guys are awesome. We'll see you later. Peace.